Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand today is park assist systems. So we're talking about more than, and it is more than, just a little beep when you get too close to an object, or maybe the rear backup camera that you might have on a car. Oh no, they self-park now. They can park themselves. You tell them where to go and they will go there. Now some of it I think maybe it has gone a little too far, and we'll talk more about that at the end. But did you know, to start off, that parking assist systems have actually been around since at least the 1930s? I haven't found anything earlier than this, but there is a patent from the 30s by a gentleman named Brooks Walker that uses the spare tire in the vehicle to actually get you out of a parallel parking space. We actually found an old newsreel style video that actually shows how it works. It's kind of neat. It's only a couple minutes long, so let's take a look.
With new cars getting bigger and parking spaces getting smaller, at Piedmont, California, an inventor has developed something to soothe the motorist's headache by putting the spare tire to work. He calls this device the Park Car and says it can be installed on any model. Watch how it works. Taking power from the drive shaft, the spare tire swings the rear end into the clear. Then he just retracts the spare, backs into the street, and away we go. It's handy for parking in inaccessible garages, too. Here's a narrow driveway, but with the spare tire put to work, the car can turn a complete circle in its own radius, and parking is simple indeed. Even the worst driver can make the garage without denting a fender with the aid of fifth wheel driving.
Now, I will say that last claim, looking at that car going around in the driveway, if you went a little bit further, you're definitely going to dent that fender. So I don't know about even the worst of drivers. But that system, like I said, from the 1930s, didn't really take off, though, because it was really expensive for the day. About $175 is what he was charging, which is more like $3,200 today. So not really an option anybody picked up on, and it didn't really take off. But that was our initial early, far back as we could go to figure out park assist. Maybe there was something a little before that. I'm sure there are multiple chances at it after that. And then it brings us to today. So we're going to fast forward to today and what all is out there and what is available out there. There's really three main park assist system types. So we have passive, which gives you either an audible and or tactile warning to the driver. So that's where it'll beep and beep faster and faster and faster the closer you get to an object. Perhaps it vibrates the steering wheel. Perhaps it vibrates your seat. That's a passive system. You don't really have any way of observing what's going on. Then they have an active system, which can take control of the steering, brake, and acceleration. Sometimes it's just the steering and you need to operate the brake and acceleration. Other times it'll drive the vehicle completely autonomously into a space, either parallel or perpendicular parking. So I thought that was kind of interesting. And then remote controlled now. So we've gone so far where you get out of the car, and we'll talk about this at the end. You get out of the car and then you tell it where it needs to go, and then it parks itself with you outside of the vehicle. Now, I don't know necessarily how good of a thing that is for a consumer. I mean, it seems like an awful lot of extra work to actually have to set it up, then get out of the car, and then we'll walk through it in a little bit, and you'll see all the steps that you need to take to get this car parked. And I think it'd probably take half the time to do it on your own without any help. But for those spaces where it's really tight, or maybe you park and you come out and then somebody all of a sudden parked really, really close to you and you can't get in the door, there's a couple useful things that could be used for. But what manufacturers have been doing today, if we think back to that 1940s newsreel, that's a lot of complex stuff going on there, right? They got the motors, and it drops down and it runs off the drive shaft, and you got to use the gas pedal to accelerate the wheel and all that stuff. Well, and that's pretty wise engineering, I would think. It seems like a pretty good idea, but once again, it didn't catch on. So nowadays, if we think about it, there's so many sensors on a car. Really, all it comes down to, it doesn't add any extra weight. It doesn't really add any extra stuff to the car, no extra mechanical stuff to the car. Really, it's just coding. I'm adding extra lines of code to the vehicle in order to take care of this. And it is pretty interesting how far they have come in this sort of thing, right? So vehicles have had radar for years. They've had ultrasonic sensors for even longer. They've had cameras, especially backup cameras, for a long time as well. I remember installing those accessories in the early 2000s. Same thing with ultrasonic sensors. You drill 4 holes in the bumper, you put some sensors in, you get a little beeper that goes in the car. It's not all that complicated a system. But nowadays, what manufacturers have done is they've taken all that stuff, and with sensor fusion and optical recognition technology and things that they're using, and we can get the car to park itself at this point. Right. So think about ultrasonic sensors, right? That was one of the original self-park or park assist warning systems. And that's really pretty much all they're used for, is for park assistance, right? So it works by transmitting ultra high frequency audio waves and then calculating how long that wave takes to bounce back at the car. Depending on how the system's set up, could be 30 feet away at most, could be 10 feet away. It kind of depends on how it's set up and how powerful the transmitters are. But it's going to transmit these ultra high frequency waves. They come back, and depending on how fast they come back, that's how the car can calculate, well, how far away is this thing? And really, that's all it's used for. We got all these other sensors around the vehicle, but really park assist, that's really what it's used for, is just the ultrasonic sensors used for park assist. Now, if we were to take a look at a 2014 Cadillac ATS, that's a 10-year-old vehicle here, and that has park assist and optional front park assist as well. So you could have a rear park assist by itself, or front and rear park assist, depending on the option code you had for the vehicle. So if we look at this one where it's front and rear park assist, so when an object is within a measuring range of a sensor, the ultrasonic pulse is reflected and is received by the sending or a neighboring sensor. That way it can kind of know where it is. It's kind of center left or center right, what have you. The sensor converts this signal into a voltage signal and sends this signal to the parking assist control module. Parking assist control module evaluates the received sensor signals. As soon as an object is within the measuring range, the park assist control module sends a message via serial data to the radio and or seat module to provide an alert signal, I would say, and or. Because the radio will give you the beep, the audible tone. The seat module will vibrate in this case. Park assist system can detect objects greater than 3 inches wide and 10 inches tall. System cannot detect objects below the bumper underneath the vehicle. Park assist can be activated and deactivated by pressing the park assist switch. When reverse gear is selected, park assist is automatically activated. By subsequently pressing the park assist switch, the parking assist can then be disabled. The control module carries out a self-test and monitors the sensors for electrical and mechanical faults, monitors the power supply for each sensor and the sensor signals, which need to alter when the vehicle moves. If this is not the case, the sensor is acoustically blocked or faulty. Mud, ice, and snow may cause obstruction of the function of the sensors. Park assist control module also checks whether the correct sensor type is installed. If any of these tests fails, the DTC with corresponding symptom is set, the parking assist is deactivated, and the parking assist indicator and instrument panel cluster is activated. So it can throw a code if there's a problem, and that could help you out because these have been around for a while. This is a 10-year-old car. This is more than likely probably not coming to the dealer. If they have a park assist issue, it's probably might be coming to you. So this is stuff to get spooled up on, learn about. We've been talking about ADAS in general for quite a few years now. So we're doing this class to kind of just make you aware of the state of where we're at right now, and it's come a long way since just these parking sensors. There's an example of what the parking sensor would look like, though. It clips into a little clip in the bumper, and then it emits through that and allows it to work. Now, they are a fairly simple item. Power, ground, and signals, all it really is. So if I were to test it, there's actually tests for this. You can go in, you can back probe at the sensor to test the sensor, make sure it's working, make sure it's got power, make sure it's got ground, and then make sure it's emitting a signal when the vehicle moves. So all fairly simple to test, but you need to know how to test them. You kind of need to be able to get underneath the vehicle and test them, and the vehicle usually needs to be in gear and or moving. But if you can overcome all those obstacles, you can test it and make sure you're not replacing the wrong sensor, or maybe there's another problem. Maybe it came back from a body shop and they put too much paint on the bumper. That happens. That's especially for radar too. That can cause issues with radar. But for these systems, that's a fairly simple system. Every sensor has one individual signal wire that goes in, and then it's able to judge where that obstacle is in space. Also, they use cameras. They don't really use the radar too much that I've seen anyways. I'm sure there's probably a manufacturer that does, but mainly it's ultrasonic sensors and cameras, so the car knows where it's at. So a camera works by turning light into electronic signals. So instead of turning sound into electronic signals, which sound is an electronic signal in a way, at least when it's recorded or emitted, but a camera will turn that light. So here's our lens on the camera, and then you see this gray flat thing right there. That is the sensor chip, where it's actually the photons from the light will hit the chip, and those turn into electrical signals that go back to a processing unit, and then it's able to, it's got a processor right there, goes back to a processing unit, and then it's able to, at this point, optical recognition can actually tell using a mathematical equation whether or not that space you want to park in can fit the car that you have. And then the computer can do calculations and figure out what angle it needs to do. It's all, like I said, it's all code at this point. You don't really need to do anything else but write a program that will allow it to do that. And I'm sure that's quite a complex program, not to belittle how much work needs to be done. But really, in order to upgrade it, it's just a software upgrade at that point. Because you're taking the sensors and it's just learning. I'm sure maybe it uses machine learning and all that as well. So with the camera, we know multiple applications for cameras, lane departure warning, especially for the front camera, traffic sign recognition, same thing. It can tell what the speed limit is supposed to be, etc. And then surround view and parking assist are kind of tied together, right? So it can be used for the 360 view around the car to help me with my parking, or it can be a rear camera to help me with my parking, or it uses it as an input to tell the car where to park. So we take an example on a surround view system on this 2016 BMW. There are 5 cameras, front right, front left, right mirror, left mirror. That's the actual control module. And then there's one in the rear of the bumper. So depending on how the lens is set up on the camera, it could have a 180-degree field of view. I bet you this one in the back probably does. So it's able to see the entire back of the vehicle. So if I can sum these cameras together and stitch them together, which is what it does, that gives you that overview that's around the vehicle with pretty good accuracy as to what it is. So there's where it would be in the mirror, and that seems like it's not the best place. I've seen worse, but that one seems like it might get a little scratched. It could definitely get some mud and definitely could get some snow on it as well. So just be careful. And when you replace the mirror for any reason, that needs to be recalibrated as well. Or if you mess around with the mirror, take it off, put it back on. Here's the basic block diagram. So we have our 5 cameras around the outside of the car, and then we see the video control module, a bunch of other different modules that are responsible for various things when it comes to the surround view camera system. FlexRay bus, CAN bus, LIN bus running the cameras, turning them on and off, and then we actually have shielded wires coming back into the vehicle. So in this example, you can see those shielded cables that go. That is a proprietary connector. It's kind of looks like an S-video connector, if you know what that looks like. It's just like a 5-pin connector, kind of round. And it plugs into this video processing module, and that sends the signal out to the head unit, which would be the display. So let's get into a little deeper dive on a couple of these vehicles and a couple of these systems and how they work. And as I was doing research, I saw, Ford had a pretty good system out there. And so I picked the 2020 Explorer, and much to my luck, I guess, it actually has 3 different types of systems that could be on there, depending on how you option out the vehicle. So I'm able to cover the 3 types of systems on just one vehicle. So this one right here, we have a reverse park assist that has an audible parking aid system. So that is the beeps. So the rear parking aid system calculates the distance to an object around the rear of the vehicle using 4 ultrasonic sensors. The rear parking aid sensors detect objects approximately 70 inches from the rear of the vehicle, 20 inches from the rear side of the vehicle, and 12 inches above the ground. So if you got something that's 6 inches tall, it's not going to detect it. To detect objects behind the vehicle, the PAM, which is the parking aid module, on vehicles without the 360-degree camera, or image processing module B. I'm going to talk more about that in a little bit when we go live on the tool, because there's actually multiple image processing modules. On vehicles with a 360 view camera, supplies voltage and ground to the rear ultrasonic sensors while monitoring a signal return cycle from each sensor. Works just like the system on the Cadillac there. The 4 rear sensors share common voltage and ground circuits, just like on that Cadillac. Like I said, not a complicated system. You just want to understand how it works. Front parking aid system calculates the distance to an object around the front of the vehicle using 4 ultrasonic sensors there. 27 inches from the front of the vehicle, 20 inches to the side, and 12 inches above the ground. To detect objects in front of the vehicle, it supplies voltage to the sensor. So it's just telling you how it works in the front as well. Only objects that reflect a sufficient amount of sound waves are detected by the parking aid sensors. The surface properties, size, and composition of an object can affect the ability of the parking aid system to detect the object. Okay, and then it has camera park assist. So we could have 2 different ways that we do this. We could have a rear-only parking aid camera. So that visually aids the driver while reversing or reverse parking the vehicle. Camera system has features that provide fixed and active guideline overlays in the video image to assist the driver in aligning the vehicle, and a visual alert function that provides a visual highlight in the zone where the object is detected by the audible parking aid system. So that works in conjunction with it. And fixed means it's got just 2 lines on there that are just, you've probably seen those before. And then active is going to be, as I turn the steering wheel, it's going to turn the lines and show where the car is going to go. So that was kind of a rudimentary beginning of this active system. On a 360-degree view camera, it's going to provide several different camera views to visually aid the driver while maneuvering the vehicle at low speed. Camera system is enabled by selecting reverse gear or pressing the camera selection switch when any gear except reverse is selected. Camera views are changed using the audio system display on-screen camera selection buttons. Available camera views depend on transmission gear selection. So you can see front, rear, sides, all that, and goes through image processing module B once again. And then we have active park assist. So active park assist would be their high-level one. It is a full assisted parking system. The system assists parking into and out of. Assist out is only available for parallel parking of parking spaces. Sensors are used to detect parking spaces. So the cameras, the ultrasonic sensors. The system then steers, accelerates, brakes, and shifts gears as required to maneuver into or out of the parking space. The image processing module B uses input from active park assist sensors, parking aid sensors, and a geometrical equation to determine whether the vehicle fits in the parking space. If it is determined the vehicle will fit in the parking space, the image processing module B requests the correct steering angles from the power steering control module and the correct vehicle speed from the PCM during the parking maneuvers. So it actually does your braking gas and steers for you. System visually and or audibly instructs the operator to park the vehicle through messages in the center second, containment display, and audio system warning chimes. So it is going to guide you. It is going to do most of the work. I'm sure there may be times where you might need to take control. There's some vehicles, not this one, but there are some vehicles out there where it says take your hands off the wheel and then operate the brake and gas yourself, and it'll do the steering for you. And then, like in this example, it will do the brake, gas, and steer for you. Now, how does it know when your hand's on the steering wheel? Well, we have torque sensors on the steering wheels now, so it knows if you have your hand on the steering wheel. And then we get to this 2023 Lexus. So when I was first researching this, this was the first vehicle that came up as a Lexus with this assisted parking. Now this has a system just like I was showing you on the Ford, where it will park. You're sitting in the driver's seat, you press the button and it will calculate and it will park. It's got all sorts of sensors, right? So we got the main switch to turn it on, and then we have all of these ultrasonic sensors here. Rear television camera, front television camera, side cameras, radio and receiver. That's to show the actual display. And then it also has, and this is what I was kind of alluding to at the beginning, remote park. So it has advanced park, which is what we were kind of talking about with the Ford there, where it'll park itself. Remote park is an extension of advanced park, which allows a guest, which would be the driver, to move their vehicle into or out of a parking space using the Lexus app over Bluetooth connectivity while outside the vehicle. This is where I think we've gotten to the point where it's a bridge too far. Because if I'm going to have the vehicle self-park, why do I need to get out and stand within 10 feet of the vehicle? That seems way less safe. It says, yeah, be observant of your surroundings and stuff, but that seems way less safe. And when you see what you need to do, it seems like a lot more of a pain in the butt to do, in my opinion. But, you know, your opinion may be different, and that's fine. Now, when it's aligned directly with the space, you can use forward and reverse, and it'll just park itself in. If it's perpendicular, you can choose perpendicular parallel, and it will actually maneuver itself into a space, which I thought was kind of wild the first time I saw that. Because I had only seen front to back or parallel. I'd never really seen one where it would actually back up and do a 3-point turn and pull itself into a perpendicular space. And then it would also do this as the remote park, right? So you need to stand outside of the vehicle. You need to be in the vehicle first and set everything up and do what you need to do on the touchscreen. And then you get out of the car. You open your Lexus app. You have to be within 10 feet of the vehicle. The key needs to be outside of the vehicle as well with you. You need to pay attention to the vehicle's surroundings. It's going to show you its intended path. So it's going to pull forward and then it's going to pull backward. And then as it's doing that, you need to take this little black circle and move it around inside this white circle. So it's kind of like moving a joystick on like a PlayStation controller or something like that. Touch and move the dot within the circle until the parking's complete. And that's the car's signal to know that you're paying attention to what's going on. If you don't pay attention, if you stop or you lift your finger, then it stops, right? So that's a good emergency override, I guess. If you just take your finger off, if all of a sudden there's an obstacle that it doesn't see or something, or if it's about to crush you in between this other vehicle, like I said, doesn't seem that safe, but he's walking over to the curb. So, you know, we'll see how it goes. Then once it's parked, the vehicle shuts off and the doors lock automatic. Fine, fair enough. In my opinion, I would want to be inside the car when this is happening. I don't see any use in being outside the car for this particular application, parallel park the car. I don't know. Your opinion might be the same, might be different, but that's okay. Now, this is where I could see it's handy, right? So this will take itself out of the parking spot remotely. So say I parked in a spot and I was parked well in between the lines, and then somebody parked like right on the line or really close to the line like this person did. So now maybe I can't open the door all the way. Maybe I need to be able to get my kid into the car. This happens a lot. So I got a 4-year-old and I have to put her into the car seat. And if we're too close to the car, you got to be worried about, well, I got to hold this so she doesn't slam the door into the car next to me and stuff like that. And I need to be able to reach in and buckle the belts and everything. So this would come in handy in that case, or if it's too close. So you stand in a safe location, but within 10 feet of the vehicle. And then you open the vehicle, you open the app and you tell it which way you want to go. I want you to come out and pull right, or you want to go out and pull left or pull straight ahead. And then it'll start making the motion and allow the vehicle to exit. Then once you can get to the door, you can open the door and you can get it. All right. So that I find useful from the outside because you kind of couldn't get inside the car at that point. The other thing, I don't know how many people are actually going to use that. I mean, maybe people requested it. Maybe the engineers just thought it was a really cool idea and they put it in there, right? Set them apart in the market. But I know seems like that takes way more work than actually just parallel parking the car by itself by doing it manually even. Remote park needs a select model year 2024 or newer Lexus vehicle equipped with remote park capability. Compatible mobile device with Bluetooth enabled. Key fob outside and nearby the vehicle. Vehicle registered to Lexus profile through the Lexus app. And a one-time remote park setup needs to be completed from inside the vehicle. So I still need to do all the setup options anyway. So this is the state of where we're at. We're getting towards very autonomous vehicles. I know, like I'm not going to mention it other than mentioning it now, but I don't have slides on it. Well, like Tesla, where it knows where it's parked, it knows where you are, and it can come to you in a parking lot, that sort of thing. So that's kind of where we're at. These are more mainstream, of course. I mean, Tesla's becoming more mainstream, but they're still, as far as market share, they're not nearly as much as Toyota, Lexus. So Toyota has this option too. So there you go. They're out there. Yeah, it's a 2024, but in a few years, it might show up in your shop. So I just want to make everybody aware kind of where we're at as an industry with these systems here. And just be aware that you may start seeing some of these in the shops maybe sooner than later. And the customer complains that, hey, my parking assist doesn't work. Can you help me? So let's go live on the tool and look at those two particular vehicles we talked about. We'll look at the Explorer first. And let's go and see what we got in the scanner. All right. So, of course, if you had any issues with engine, transmission, steering, brakes, and stuff, none of that's going to work anyway. So you need to address those base issues first before you go through that. But then talking about down here in our ADAS, remember how I said we have image processing module A and image processing module B. So that can get a little confusing if you didn't know what you're looking for on a Ford. Lots of Fords have these too, so just be aware. So image processing module A is going to be your front camera, right? So that's things like camera alignment. There's also, looks like there's PMI in here as well. So I can, if I need to change the module, I can copy and paste the information. But image processing module A alignment's your camera aiming for the front camera. Now, we don't really care about the front camera for this because it uses the side cameras, and it's talking a lot about image processing module B. So we'll go in there under special functions, and then we have the 360 camera calibration. So this procedure is for calibrating a 360-degree view camera system without target mats. So there, some vehicles, maybe even this one, have the option of using a mat. It's like a 10-foot long mat with a bunch of black and white squares on it. You have to spread it out around the vehicle. Looks like a big circus tent. And that is a way to statically just do them. But this is for dynamically, so I can drive at approximately 5 to 10 minutes or possibly longer depending on environmental conditions. Preconditions, if the module was replaced, I need to do a PMI. Front and rear camera is replaced, perform a Lin new module initialization in the module. Perform a self-test, address any DTCs, and the battery voltage needs to be 11.8 to 15 volts. Verify no active codes, verify all camera lenses are clean, verify all doors, deck lids, and tailgates are closed, mirrors are in normal driving position. Suspension is normal driving mode if equipped with adjustable suspension. That's important. Verify you don't have a trailer attached or other camera obstruction. Do this in daylight. Perform the procedure when visibility is clear with high contrast scenes not disturbed by strong rainfall or snow. Recommend driving on a normal asphalt or concrete road surface. Avoid road surfaces that have smooth and uniform appearance like a snow blanketed roadway. Making sure the ignition switch is on and engine is running. 2 driving phases to properly align the camera. Phase 1, you're going to start driving the vehicle in forward gear. Drive with the steering wheel straight. Drive for approximately 15 miles an hour for approximately 1 minute. After 1 minute, pull over to a safe area away from vehicle traffic. Come to a complete stop. Leave the vehicle and drive and remain stopped. Activate the camera view on the touchscreen display. Press continue once complete. So you got to run through all that. Press the button on the display, then hit continue. It's now in calibration state. Status screen should be viewable on the vehicle touchscreen display. Does it say 100%? Yes or no? We can say yes. Then it says calibration successful. If it says no, then you got to do it again, or you have to do something different. Drive very slowly over the parking designation lines while watching the corners of the 360 image for stitching quality. So make sure you don't have any weird warping or anything. Lines should look continuous. Okay, and then that's how you would calibrate the camera. So you drive the vehicle. So that doesn't need any special targets, which is nice. Some vehicles do. Let's look at the parking aid module real quick as well. That one. So that's that new module initialization that they tell you to do. When you replace the image module B, you got to do that as well. Really not anything else to do in there. So let's go to our service information as well. Platinum. Okay, and then we'll do parking assist. Parking assist. And look, there's TSBs on it. So we go in TSBs, let's look in collision avoidance. And let's see. Parking aid, pre-collision, and collision avoidance system diagnosis with no DTCs present. This could be something that happens to you. You could have a customer complain of a problem, but yet no problem. Or no codes anyways. False park aid alerts with no DTCs in the park aid system are usually due to snow, slush, fog, salt, ice, frost buildup, car wash, and or heavy rain. And then there's what it looks like right there. There's the sensor itself. There's a little shroud on it as well. So make sure it's clean. All right, and then you can just kind of tells you how to go through and double check those. So it's always good to check the TSBs first in case I have an issue. Let's go to component operation. It's going to walk you through a bunch of different systems. It's going to walk you through the 3 different systems that I just talked about. And all the information I showed you on the screen came out of Shopkey. So it's right from Ford. You know, there's one of the pictures right there. And that just kind of tells you how it works. So good to research before I work on any system either. I just want to kind of be aware of what's going on with the system and how it works and how it's expecting to see signals and so on. So always good to know. And then after repair, what do I need to do? It's going to give you a couple different system checks for azimuth and so on and so forth. So a couple things you might need to do to realign that active park assist as well. All right, now let's look at the Lexus real quick. So on the Lexus, it has blind spot monitors, which is really going to be radar. Circumference monitoring, clearance warning is going to be another one of those. So this is be like your park system. So special functions, we have customized settings. So I think this will show. Oh, it just goes through and does it. So I can't show that in the simulator, but there is it talks about it in the OEM information on how to reset and relearn things. There's a customized setting that needs to be done, ECU calibration that needs to be done. And then circumference monitoring camera is going to be a 360 camera as well. So that'll give you like data saved, data write when you're changing modules and stuff. Then let's look in repair information. Okay, and then I'll do parking assist again. All right, and then component OEM testing. All sorts of different information on there. Caution, notice, hints, service information, precautions, how to proceed with troubleshooting, trouble code charts, data lists, active tests. If we pop down there, it's going to tell me all sorts of different data lists, different tests to do with scan tools, stuff like that. So it's pretty involved. And if you're going to work on one of those systems, you're going to want to know as much as you can about it. So you probably want to do a little bit of research on it. For example, this customized parameters talked about that, right? So you can set the different ranges, near or far, how it detects, how it mutes, how it judges obstacles, etc. So, and then how to calibrate it as well. It's going to tell you what you need to do when you need to calibrate it. So, it's not just a beep. It's not just a vibrating seat. It is cameras and sensor fusion and ultrasonic sensors, and they're parking themselves now. So it's going to take us a lot longer, I think, to get fully autonomous vehicles because that's a lot harder math to work out and all that. But it can at least park itself and it can unpark itself, which I think my wife would like very much. So she probably, if she's watching this, she probably wants one of those right now. So anyways, that is parking aid system, parking assist systems. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video, and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.